I'll mute myself.
Okay. Hello, everyone. Sorry, I couldn't, my mute and unmute disappeared for a second. Thanks so much for coming out on a Wednesday evening. I'm happy to be here. And yes, this is building off of the talk I gave about a year ago to the Natural History Society of Maryland for their Archaeology Expo, which was focused on proboscidean, mammoth, and mastodon hunting in Maryland. So as a tie over, you can see this kind of intro screen. And something to note about this intro screen, you can see in the bottom right corner AI. This is generated with Google's AI. So a lot of the images now that you'll see in this presentation are AI generated, and it's been fun to work with AI now to try to generate photos and diagrams and things to show people what I'm thinking about in a way that otherwise I'd be on the internet trying to rip off someone else's work. So this is open access AI now. I'm going to talk about tonight studying Maryland's Ice Age peoples and research I've been conducting over the last year or so. And as Matt said, I'm Zach Singer, State Terrestrial Archeologist at the Maryland Historical Trust. All right. So first, just some background before we get into the specifics of the sites I'm looking at. So we're all on the same page in what this topic is that we're going to be investigating tonight. It's studying the Ice Age peoples in Maryland, the first peoples in Maryland. And sometimes you'll hear people refer to those people as Clovis people. That's based on the Clovis technological complex, which are artifacts that were found near Clovis, New Mexico. So really we're looking at stone tools and people, and from those stone tools trying to learn about the people who made them. And these people lived about 13,000 calendar years before present, so at the end of the last ice age. In archaeological literature or other archaeological talks, you'll hear archaeologists refer to these early people as Paleo-Indians or Paleo-Americans. Paleo just means old, and we know Indians or Americans referring to the native folks who live in the USA. The way that archaeologists, again, try to study these people primarily is through artifacts that people left behind. And 13,000 years ago, based on the lack of good preservation of most archaeological sites, what we're looking at for the most part are stone tools, because stone is strong and hard and doesn't rot very often. And so we typically, as archaeologists, use stone tools that we find to try to study people in the past. And this is particularly true for these very early archaeological sites. And so two things I want to talk about in a little more detail, because I'm going to mention them for the sites I'm looking at specifically, are fluted projectile points and overshot flaking. And these are things that define Clovis technology. So ways that Clovis hunters or Clovis people reduce stone to make hunting tools. So I'll go into that in a little more detail. But this image that we all have as people who are interested in archaeology, when we think about these early people in North America, we get this idea of big game hunters. So the first two slides, you've seen images of, at least AI generated images of people hunting mammoths and mastodons. And that's a pretty kind of fun thing to think about. And these first sites, like the Clovis type site near New Mexico, was found first as a paleontological site where people were excavating mammoth bones, and then they started finding stone tools embedded in those mammoth bones. And so that was kind of an eye-opening moment to say, wow, there were people in North America around at the end of the last ice age hunting these now extinct megafauna. So this is still kind of the image that really is striking and evocative. And certainly it is, Paleo-Indians, Clovis people did hunt these now extinct megafauna, but their lives are more complicated, just like ours are, than just boiling it down to hunting of one animal. All right, but getting into it, so what is a fluted point? Fluted points are the types of hunting tools that Paleo-Indian people made. And why are they called fluted points? On the left image, you can see a fluted point, and I've outlined in a kind of reddish pink wavy thing the flute on a fluted point. It's a removal from the base of the projectile point up towards the tip that creates a groove, a thinned area where the projectile point could then be hafted with a foreshaft and tied with sinew. So in the central image, you can see a Clovis point where it's been hafted. And so what most people think is that fluting, the removal from the base towards the tip, is to thin the stone to facilitate hafting. So basically that's all a fancy way to say it was how people like to tie their pointy stone onto a stick to go hunting. But these styles change through time. So for instance, in the center, you have a Clovis point where the flute is about halfway up the projectile point. That's about 13,000 years old. On the right, you have a Folsom point. The flute is all the way to the tip. So that's a change in the idea of how far a flute should travel to then facilitate hafting. And so that those Folsom points are about 12,000 years old. So a little bit, I mean, about 1,000 years younger than those Clovis points. So those are fluted points, and we'll talk a lot about them. But the main idea is all the people who make fluted points thought that the best way to haft their projectile point was to thin it from the base towards the tip. Later in time, and we won't see many of these, but later in time, people do things like put notches on the side or create long stems. There are other ways to haft a stone projectile point, but Paleo-Indians like to flute. And so it defines them in the archaeological record when we find those artifacts. As part of fluting, there is diagnostic debitage, meaning the trash or waste, the chipping debris that is produced when creating a stone tool. And in the archaeological record, we see things we call channel flakes or end thinning flakes. Those are the removals from the base towards the tip. That is the flake that comes off to create that flute. So in the archaeological record, we can look for those things to try to identify the production of fluted points, even if the fluted point is made and then taken away to go hunting somewhere else. By finding those channel flakes or end thinning flakes, which is the example on the right there, that shows that a fluted point was produced in the area. And the way those are recognized is based on the flake scars coming from either side of the flake and meeting in the center to create a medial ridge. So that's one of the big indicators. And then lastly, another type of debitage that is diagnostic for identifying Clovis people making stone tools 13,000 years ago are things called overshot flakes. This is chipping debris where someone is making a hunting tool, like you can see on the right, a biface, meaning worked on both sides. And they're removing large flakes that travel from one edge of the biface all the way to the other. And so that this idea of how to strike flakes from one side of the biface to the other and do that systematically is something that typically only occurs about 13,000 years ago, where with Clovis biface technology. You don't see this style of biface reduction occur later in time. So when you find that type of chipping debris in a decent quantity, you can be pretty confident you're on an early Paleo-Indian site, more specifically a Clovis site. Okay, so I've been talking already about these sites ranging from 13,000 to 12,000 calendar years before present. So just a little background about that. Well, how do we get to these dates? What am I using to say that sites are that old from the end of the last ice age? And the way that these, not like you have to squint to see all the little words in here, but the way that this happens is through radiocarbon dating. So in short, there's based on neutrons in the atmosphere, sun rays hitting nitrogen-14, that interaction creates carbon-14, which then gets incorporated into carbon dioxide, which we all know trees respirate. So either people use the wood and burn it, and it becomes charcoal, which is datable, or animals eat plants like grass or leafy things that incorporate the carbon-14, and then people can eat those animals, and their bones have incorporated the carbon-14, and so when plants or animals die, they stop exchanging carbon with the atmosphere, and the amount of carbon-14, it's an unstable isotope. So it's radioactive. So it decays at a known half-life, which is 5,800 and 5,370, I think, plus or minus 30, something like that. It's around 5,000 years is the half-life for radiocarbon, carbon-14. And so by measuring the amount of carbon-14 left in an organic remain, you can then factor in how long ago that object died. So for the purposes of archaeology and saying that these Clovis points are 13,000 years old, like the Shawnee-Minnesink site in the upper left, what's happened is archaeologists have found fireplaces in association with those hunting tools, and they've dated the charcoal in those fireplaces. So a big part of archaeology is careful excavation to document the context of artifacts, knowing that how artifacts are associated with each other, and with features like fireplaces, we can then associate them and use that for radiocarbon dating. So that's all to say that when I say these sites are 13,000 years old, it's based on finding these hunting tools nearby fireplaces. Okay, so that's the background. Now we're going to get into some of this specific research that I've been working on lately. And this is all an outgrowth of the Maryland Fluted Point Survey. Here's a basic image of fluted points that have been documented throughout Maryland. And first to say, all of this work, I'm fortunate to stand on the shoulders of giants. So this is work that other people have started and done the bulk of, and I just get to be lucky enough to play with it and study it and present on it. So specifically want to mention Lois Brown, who did a master's research on fluted points in Maryland in the 70s, and she documented the vast bulk of these fluted points. And so I'm using her records, which I've now digitized for most of this material. Based on that, there's over 107 fluted points in Maryland. You can see some of the different clusters. I've highlighted the mid-Potomac area. I recently published a paper on that area, and I talked about that last year for your group. So I'm not going to mention that in much more detail, but just to say that by documenting fluted points across the state, we can sometimes find interesting clusters which are worth investigating in more detail, which is something I've been doing now. Another point of note is to think about the environment 13,000 years ago and how it is not the same as the present. So we've already talked about how it's the ice age, so it's colder than present. There's likely it's likely kind of more subarctic in feel than it would be. It's not temperate like it is today. But another huge thing to think about is that the Chesapeake Bay did not exist 13,000 years ago. It was the ancestral Susquehanna River. And so here on this map, in the kind of red squiggles, you can see the Cape Charles Paleo Channel, which is the likely river path for the Susquehanna River 13,000 years ago. So when people find fluted points today, walking the shorelines of the Chesapeake Bay, it would be an easy thing to say, well, these Paleoindians were hanging out along the bay. But by doing these environmental reconstructions, we really know, no, they were actually inland on these upland interfluves. And just because of the current status of the bay and erosion and sea level rise, these 13,000-year-old sites are being exposed. Okay, so we'll go back for 1 sec. So the site I'm going to talk about first that I've been doing a lot of recent research on is the Barton site, which is in Allegheny County. So actually in an area that was just impacted pretty heavily by the terrible flooding last weekend. So the Barton site was found by John Dominic. You can see him in the center. He's still active in the archaeological community in the Western chapter of the Archaeological Society of Maryland. And he is an avocational archaeologist and field collector. So his pastime, what he did for fun was go around plowed agricultural fields and find pre-contact artifacts. On June 11th, 1981, John made a pretty important discovery. He found a Clovis point, which you can see on the right, made of Shriver chert, which is a Western Maryland variant of chert. He found that in a field at the Barton site. And John took, understanding that this was an important discovery, filled out that card you can see on the left. So he drew a map of where this discovery occurred. And this is truly a Clovis point, meaning it's 13,000 years old, based on the short flutes. You can see how short they are, and the shallow basal concavity. So it's the base doesn't flare up very much. So John is the first person to recognize that there was a 13,000-year-old archaeological site at the Barton site. Since then, Dr. Bob Wall at Towson University has been investigating this site for about 30 years at this point. And Bob, the site's on the floodplain of the Potomac River, the northern branch of the Potomac River. And so every time the river floods, well, not every time, but frequently when the river floods, it then builds soil at the site, it aggrades. So it's on a floodplain where there are archaeological components that are deeply buried by flooding at the site. And so Bob has excavated down over over 9 feet below the surface in some instances, and documented archaeological occupations through time at Barton. So here you can see a soil profile. The top of it is the plow zone, and then as you get deeper, you get different earlier occupations. So everything, this site has evidence of archaeological components from the contact period, so 1600s, all the way back to the Paleoindian period, 13,000 calendar years before present. And for the purpose of this talk, the Paleoindian period is the Paleoindian occupation at the site is found around 190 centimeters below surface, or about 6 feet below the surface. I first got introduced to this site in 2005 as a high school intern at Towson High School. So you can see my old camera here, probably a flip phone I was using. So as a high school intern, Bob helped me get into archaeology by showing me these artifacts and having me wash and catalog them. And I continued that analysis as an undergraduate student at University of Maryland. So I've been thinking about this site and studying the stone tools that he recovered from the site for 20 years now. So what did Bob find at this 6 feet below the surface? He found overshot. He found many of them, both from biface reduction and as well as earlier stage core reduction. So this whole process of turning chunks of stone into hunting tools. There's evidence for overshot flaking, which again is something that only seen during the Clovis occupation in North America. He found some core fragments, meaning that the stone that people are finding to make these stone tools are somewhat nearby because they're carrying them to the site. He also found evidence of bifaces, the things that were being made. In this case, the one it broke, but the flakes, the chipping debris fit back onto those tools that were being made. So showing that the context of the site is good. The tools that were being made, even though it broke, was dropped nearby, and the chipping debris from making that tool was also found nearby, and they were able to put them back together. He also found scraping tools, unifacial scraping tools, meaning they've just been flaked on one surface. Unifacial scraping tools are another classic type of formal tool that Clovis and other Paleoindian people used. In later time periods, you don't see many unifaces, mainly bifaces, meaning they're worked on 2 faces. But here you see on the left 3 unifacial scraping tools. Most use-wear analysis and protein analysis suggests that these scraping tools are used to scrape hides, animal hides, to make tailored clothing. Again, it's the Ice Age, so it would have been cold. People would have needed well-fitting, tailored clothing to stay comfortable and survive. He also found a channel flake and end thinning flakes. These, again, are the process of making the flute on a fluted point. So this shows evidence that fluted points were produced in the area that Bob was digging in. Okay, so flash forward to 2024. In August, we returned to the Barton site. And this was with grants, facilitated by grants from Archaeology X, which is Brian Fritz. You can see him in the center there in the maroon, his public archaeology company, and the Archaeological Society of Maryland, which is our local nonprofit archaeology group. With grants from them and with support of the Archaeological Conservancy, which Kelly Berliner is the Eastern Regional Director. You can see her on the top left. This project was facilitated, which I'm going to talk about in more detail. And in the center there, in the right, in the kind of reddish shirt, that's Bob Wall, who again has been studying the site for 30 years. You can see here where we're set up under that kind of white tent. We're along the bank of the northern branch of the Potomac River. So behind those copse of trees is the river. And we're in an agricultural field, which is owned and conserved as an archaeological preserve by the Archaeological Conservancy. So we did a few things when we went back out to Barton. The goal, again, we're talking about Paleoindians here. My overarching research goal was to study that deeply buried Clovis occupation that Dr. Wall had found at Barton, but also knowing that there's important archaeological resources throughout that whole soil column, really study the whole soil formation process at the site and how the site has been formed and preserved over time. And so we started with soil studies. We had soil scientists, Dr. John Watt at the site, and geoarchaeologist, Dr. Dave Leslie at the site. So we did some traditional hand augering as well as some terrestrial vibrocoring using a concrete mixing head to rapidly vibrate these metal tubes to drive them into the ground and collect continuous soil columns. So you can see in the center there some of those soil columns. So they're great because you get a full continuous sample of soil to study in more detail. And we used those vibrocores to create this fence diagram to better study the soil formation at the site. And again, it's small, but we also radiocarbon dated flecks of charcoal throughout these columns, which show that the site has been grading and building and preserving archaeological context for at least 16,000 years, if not over 30,000 years. So clearly there's a Clovis occupation. There's potential for this site to preserve older occupations if they were to exist, or if people were to have lived here at the site at that time. But for sure, the site is deeply buried and contains cultural occupations as well as soils that date to at least 16,000 years ago. All right, so the kind of other thing that was really exciting that I wanted to do at Barton was to deploy the Paleo Digger. This is a machine that was invented by Brian Fritz, the guy who runs Archaeology X, and he is an archaeologist as well as he was a farmer, and he's clearly a very impressive inventor because he invented and hand built this machine, which is a drill mass power bucket auger. So it's a way to excavate very deep test pits mechanically. It's the only way to get down. He can dig down to 7 meters below surface and do it in a way that is this very similar to how archaeologists excavate shovel test pits. It's 50 centimeters in diameter, which is the same as a square shovel test pit that most archaeologists dig. And it digs in 10-centimeter levels, so it can capture the depth of artifacts as you dig down, which is what you want to do at these floodplain sites. So the goal at Barton was to dig one of these Paleo Digger pits every 8 meters along a transect to try to document the different occupations at the site. So the contact period, the early woodland, so on and so forth, getting down to the base of excavation, which is the river gravel, which is about 9 to 10 feet below the surface. And again, I would get very excited if we found a new Clovis occupation area. So again, just to say, Brian is a very talented guy. We're really lucky to work with him and have his interest in helping at the Barton site. And so he designed and invented the Paleo Digger, which is, I mean, a really awesome and useful machine, which I'll show you coming up. So it was him and his father who hand designed and hand welded this machine. And there you can see the first iteration of the Paleo Digger from fall of 2019. This machine runs on the hydraulics of a skid steer. So hopefully this works. Here's going to be a quick video showing how the paleo digger in action. So here we're at the Barton site. It spins and it digs in 10-centimeter levels. It stops, it counter rotates and lifts up, trapping the soil in the bucket. The bucket kicks out and the dirt is dumped into another tub. That dirt is then pre-screened through a rotary screen, which is 1/4-inch mesh, to help get some of the loose soil out. But then still the vast majority of the hard work is by volunteer archaeologists who are screening that soil and keeping track of the artifacts they find in those 10-centimeter levels by carefully using labeled bags and keeping track of where the soil came from by both location and depth. So the vast majority of the work is still very hands-on, very labor-intensive screening of silty soil to find artifacts. But we were able to dig 10 feet below the surface, which would be impossible by hand. And the only way that we can find these deeply buried sites in a strategic way. So Bob Wall, when he found the Clovis occupation at Barton, was excavating for like 3 months to get down that deep with volunteers the whole time. I can't currently budget 3 months of my time to be out in the field every day. Bob has run field schools and had great connections in Western Maryland to be able to spend that bulk of time to invest in those deep excavation units. We were out there for a week and we were able to dig down deep, again, solely because we had this technology. All right, so what did we do? We excavated 15 paleo digger pits, really 10 we got down deep. 5 were too compact to dig, but Brian, and those were the ones that were way in the farmer's kind of field line path. So Brian's tinkering and thinking of ways to invent to be able to dig through those more compact areas too. What did we find? Well, here's an example. So this pit is down over 6 feet below the surface, and in the wall, I think I have it highlighted. Yes. We found a feature. We found a burn stain. You can see it's charcoal rich. It's very dark in color. We radiocarbon dated that feature. It came back with 2 dates, which don't overlap. So that's kind of weird. But nevertheless, when you calibrate both dates, this burn stain dates about 10,000 calendar years before present. And that would be associated with an early archaic occupation at the site. So you can see some of those corner notched and serrated points that would be associated with this occupation. So based on this shovel test pit, this paleo digger pit, we now have an area with an intact, at least a portion, we found part of it, but a portion of an intact cultural feature that's 10,000 years old that would be great for a more formal, meticulous excavation to study these 10,000-year-old occupations in the early archaic at Barton. But as you can see from this picture, it is tough to document the deeply buried stratigraphy with the paleo digger holes. Takes a lot of leaning in, a lot of careful trying not to fall headfirst into a 10-foot deep hole. But we're working on inventing different tools that will help us better document the soil profile besides me with a shovel at the bottom. Another deep test pit, this one was 3 meters below surface, so over 9 feet. You can see at the way bottom hitting the river gravel, so it's a good way to stop. We know there is a stopping point. The site doesn't go forever into the ground. There's a stopping point, which is river gravel, and above that is those silty soils that have preserved archaeological occupations. So here's some of the finds around 6 feet below surface, which again is where Bob Wall was finding his Clovis occupation at the site. We're finding chipping debris. Of particular note in this case is the flake on the right, which has that big circle in the center of it. That is a pot lid spall. Those are produced from heating, meaning that flake fell into a fire and the pressure from the heat of the fire popped out that pot lid. So even though we didn't find this time a fireplace, a hearth, a 13,000-year-old hearth, by finding that flake with that pot lid spall, I think there's high potential for a fireplace somewhere very nearby. And based on finding a 10,000-year-old fireplace at the site, it's likely to be preserved. So we now have another area to go back to if we want to try to find a fireplace associated with this 6-foot buried site. which would be really important because those fireplaces are one of the only chances to find any sort of preserved organic material, meaning burned bone or burned nutshells or burned wood, to figure out what people were eating and what sort of wood they were burning even. So trying to reconstruct the environment nearby Barton. So finding fireplaces is really important to learn more about things that typically don't preserve very well in the archaeological record. Just as an example, here's some weird AI of someone making a stone tool by a fireplace. But that's the point, is someone's making a stone tool and flakes fall into the fire as they're making a stone tool. And that's what produces those flakes with the pot lid spalls. So I'm pretty confident that we're nearby a fireplace, which is worthy of investing the time and energy to open up to try to find. Okay, another test pit around 2 meters below surface, we found a unifacial scraping tool, an end scraper. And this is a classic hafted tool that would be used again to make tailored hide clothing. It's for scraping the hides. This would fit very well in any Clovis assemblage. Here you can see an example. It's a hafted tool. That's not a Clovis end scraper, it's just an example. But that's what it would look like. The stone's at the top, it's tied on with sinew, and there's a bone or a wood handle, again, for scraping hides. We did also, we're documenting the whole archaeological occupation at Barton from top to bottom. And so we also found evidence around a little over 3 feet below the surface. We found a Brewerton corner notched point, which dates to about 6,000 calendar years before present. So we are finding other occupations as we go. So anyone who's interested in studying that time period, we have a really great spot to go do that. We found a utilized flake, which is on the bottom. That's a quick handheld tool where the side is used for a quick cutting task. But when you're cutting with stone tools, the edge gets damaged. And so there's edge damage indicative of a cutting task with that bottom flake. And I kind of tried to highlight the edge that's used. And then for me, one of the most exciting discoveries was, again, at 2 meters below surface in one of these test pits, we found 7 flakes. And so the bottom 4 are chert, probably that Shriver chert, and the top 3 are some sort of chalcedony, which I don't know where it's coming from. But that's a pretty good concentration for one of these 50-centimeter holes. When people are making stone tools, again, another kind of odd AI, but when people are making stone tools and they're chipping the stone, the debris, the chipping, the flakes spread around them. And so you get a concentration, you can see lower left, a spike, like it's kind of like an egg yolk and then the white around that. So you get a hot spot of where the chipping debris clusters. And so finding these 7 flakes all right nearby each other suggests that we're somewhere in a stone tool production area. And that would be another area to be worthy of opening up to investigate further, to try to get to the center of that production area. And hopefully we would find diagnostic debitage like channel flakes from fluting points, or even if someone broke a tool before they finished it, find that broken tool to figure out who was there creating this chipping debris. So all told, we found another cluster of artifacts 6 feet below the surface, which is likely Paleoindian in age based on the radiocarbon dates from those soil columns, as well as based on the artifacts that Bob Wall has found in his excavation. And this was done in 5 field days. So the only reason we were able to do that is using this innovative paleo digger technology. And because, so building on that, when people study these early Paleoindian sites or Paleoindian sites in general, there tends to be these campsites tend to be very well organized in space. So there tend to be areas where people are living, so like houses. There are areas where people are making stone tools. There are areas where people are scraping hides. There could be other activity areas, discard areas, fireplaces, so on and so forth. And so when you excavate just one test unit in one spot, you get one portion of the site. But by being able to dig these paleo digger pits at a regular interval, we can start trying to learn more about the spatial organization of the entire campsite. And then by finding stuff in these paleodigger pits, we can then more carefully and reasonably pick where it's worth investing the time and energy to open up these larger excavation units to better sample those activity areas. So the photo of someone digging at Barton there, again, it took over 2 months of excavating because it's a meticulous process to open up these large units and especially get them that deep. So I wouldn't want to just randomly shot in the dark. I don't have the time to do that. So by digging these test pits first, we can more carefully choose where it's worth opening up these larger excavation blocks to study this deeply buried site. Okay, I guess I'm going to switch gears. So if there's some questions, I can answer them now if someone wants.
Yeah, there's a few questions, Zach, in the chat window here. Let's see, we'll start from the top. In the Fluted Point Survey map, the number of points found decreases as you go west. Is this because Paleo-Indians use the coastal plain more, or is it because fewer people are reporting them in that area, or both?
That's an awesome question. I really like to think about that too. I start with it's probably about modern population density and where people and how those sites are found. And so on the coastal plain, a lot of these sites are found because there's a long tradition of people walking shorelines to find stone tools. And there's all this erosion, which is continually churning out more stone tools. So I think it's probably more about modern population density, and the sites in Western Maryland, there's fewer people, and those sites would almost all be sites that were plowed. And now with this no-till plowing, you're getting less of a chance to see these buried archaeological sites. So I think it's both. Although when you see those clusters of Paleo-Indian projectile points, like I was talking about briefly in the mid-Potomac, I think that probably does say something about where Paleo-Indians visited routinely and frequently, so that you find a bunch of artifacts. So it is, I think it's both, but we definitely have to remember our modern population density that could reflect finding these hunting tools.
So another question, my admittedly limited understanding is that there is or was some question about the contexts for these materials and thus the dating. Has that been resolved?
So I'd say for Clovis sites and Paleoindian sites in general, there have been a number, I don't know the top number off the top of my head, but there have been many archaeological sites where these fluted points have been found in association with fireplaces, and more are coming to light every year. And so I think the dates now we're pretty confident in the dates. Like when I say 13,000 calendar years for Clovis, that's been well established across North America.
So how do you decide where to dig?
So, well, and that's also a good question. Usually I like when someone finds something first, someone from the public finds something and reports it to me, because again, I don't want to take a bunch of volunteers out somewhere and then get skunked and not find anything. No one likes that. But in general, well-drained soil nearby water is places that would be good to camp today that were good to camp in the past. It does get harder when we're thinking about 13,000 years ago, when the environment today is so different from the environment 13,000 years ago. But in general, places that you'd want to camp today might be places where people camped in the past.
Cool. A couple others, and then we can move on here. So how far away are the nearest outcrops of the Shriver Chert used in Clovis artifacts at the Barton site?
Another good question. They're very nearby. I don't know the exact distance, but I'd say less than a mile.
Was there any fossil pollen and spores found in the 13,000-year-old soil at the Barton site?
So I want to study that, and I'm trying to raise money to do some of these more specialized analyses. There should be fossil pollen preserved in those soil columns, and we have these now continuous columns from the top to the bottom. So that is certainly an avenue of interest, of research interest for me. And if I can get the funding to facilitate that research, I will.
I would add for Steve, who asked the question, that we do have up on our YouTube channel a talk for the club from about a year ago about paleobotany and in Maryland, which is pretty interesting and might address some of that. So finally, did Clovis people across the continent transition to new fluting techniques all at the same time?
So that's an interesting question too. And there is a general trend from these short fluted Clovis points to these fully fluted Folsom-like points, or some people call them different things depending on where you are. So if you're in like the Carolinas, they call them Cumberland points. If you're in the Great Lakes, they call them Barnes points. But yes, there seems to be a transition around 12,000 years ago, maybe a little earlier, 12,300, something like that, where people start fully fluting their points. And it does seem to be across a lot of North America, a lot of North America, particularly the US. And so that's really interesting. And people argue about why, but the thing that always gets me is that people must be communicating on really long distances, and they don't have any sort of cell phones or any technology for doing that. It's from the spread of ideas from face-to-face interaction. So people were really well connected throughout all of time in the Americas. So yeah, so we do see that trend. People argue about why.
Awesome, thanks, Zach. I think that's it for questions for now. So let's carry on.
Okay, cool. So I'm going to do I'll do this one rapid fire, but this is another topic of interest for me lately. And this is studying this stone that I call weathering amber chalcedony. And this has been picked up. It was on WMAR a week ago about this study, and it's been in the Baltimore Banner. So, which just shows, again, different places that you study, different amounts of interest. So this is the site I've been studying is in Baltimore County. So I guess current population density, again, reflect interest in studying artifacts. But nevertheless, this study got started looking at this unique stone, which appears in the Fluted Point Survey. And you can see 5 examples here of this amber, amberish red chalcedony that tends to weather. You can see particularly the point second from the left from Caroline County, which it develops this kind of whitish patina. And so this is a really unique stone, which when I got to Maryland, I was like, what is this? And I was asking people like Carol Ebright, who is now retired from the State Highway Administration. And she said, we call it weathering amber chalcedony, and it typically only occurs on these Paleoindian sites. You don't see it later in time. So that gets me excited, because if we find debitage, just the chipping debris, it's a way to narrow down on sites to study in more detail. All right. So, and people, Clovis people, Paleoindians are making fluted points, and they're using this material, and it's been found as fluted points in Hartford, Caroline, Frederick, Dorchester, and Calvert County. So all over Maryland. Okay. As well as the Higgins site. And so that's what got me into this, was studying the Higgins site, which is a site near BWI. It's a Clovis site. There you can see more examples. It's pretty weathered here. This research was facilitated by a Gloria King Fellowship in 2017 and 2018 at the Maryland Archaeological Conservation Laboratory. With just a quick plug for them, they're down in St. Leonard. It's the state curation facility. It's high tech, super worth a visit. They're currently being renovated to be able to curate more artifacts. So it's not open to the public right now, but it will be hopefully by the fall, I'd say. So if you haven't been to the Maryland Archaeological Conservation Laboratory, that would be a fun trip for this archaeology club to organize. Okay. And in doing that study of the Higgins site in 2017, noticing this stone, I was talking again to Carol Ebright, and she said, well, if you think it's an interesting stone, you should study this Piney Grove site, which is another state highway project. This site was found in 2001 during an archaeological study in advance of road realignment at Piney Grove. So there were 52 shovel test pits, which came down on a lot of chipping debris of this chalcedony. And then from there, they opened up 12 test units. So you can see an example of that chipping debris in the left. And what also got me excited was that the site was shallowly buried. So it didn't have to dig 6 feet below surface to find it. You have to dig a foot below surface. But based on the context, it seemed to be pretty well preserved. There was a lot of chipping debris in tight clusters. So I studied this site, and just briefly, you can see here there's large blocky core fragments, meaning the stones from somewhere nearby, because stones are heavy. People don't carry big chunks far away just to throw them away. So if you're finding big chunks at a site, it means that the stone was found somewhat nearby. This is also cortex on the stone, the weathered outside rind. So meaning the stone was found, weathered, been sitting on the ground for a while, and then people are breaking it open to start making stone tools. So this is the reduction flakes, decortification, removing that weathered blocky rind to make stone tools. This stone, it's actually clear, so it doesn't photograph well at all, but those are end thinning flakes. So the flakes removing to make flutes on fluted points, although you have to trust me on that. And what really got me, what was surprising and I hadn't thought about before this site, was that there's all these overshot flakes. And these are diagnostic. They are produced when Clovis people make their hunting tools. So there was a bunch of them at this site. So we got two kind of separate lines of evidence here. We have from the site evidence of making fluted points out of this material. And then in the Fluted Point Survey, we have fluted points deposited around Maryland of this material. So I was like, oh, I really want to study this site in more detail. So we went back this past October, right when the Orioles were in the playoffs, and that didn't go well, but this went better than that. And the site is owned by St. John's Church. They were so accommodating and so just so hospitable. It was great to work with them. And we really thank them for letting us come out here, and particularly for tromping mud into their restroom facilities. But where the site is you can see pretty hard to access nowadays. But we had lots of volunteers who were hacking through these thorns and brush and poison ivy to conduct a shovel test pit survey. And here's research archaeologist Steph Soder, who never lets me take a good picture of her, who we used a GPS, an EMLID system to lay in shovel test pits on a grid through the woods. Here are volunteers excavating these shovel test pits. Here we dug, again, it's shallowly buried, so we can dig by hand. We don't have to use a paleo digger. We use people diggers instead. And we dug over 50 shovel test pits on a regular 4-meter interval to try to find more evidence of people using this weathering amber chalcedony at Piney Grove. Here you can see other volunteers documenting those shovel test pits using forms as well as Munsell soil charts. Okay, so what did we find? Well, not as much as I had hoped. I had, based on all the archaeology that happened in 2001, I had thought we were going to find tons and tons and tons of artifacts. Well, they already found them in 2001, so we didn't find those areas. Instead, we found 5 test pits that yielded this chalcedony, but 3 of those test pits were right nearby each other. So we certainly found another activity area where people are using this chalcedony, making stone tools out of it. And most excitingly for me, on the left, I know it's hard to see, I think I have another picture coming up, but on the left is a scraping tool. It's the first formal tool. It's a side scraper, so it's a handheld scraping tool. The first formal tool made out of the chalcedony that's been recovered from Piney Grove. And you can see it's really dirty. That's because we're going to hopefully do residue analysis to figure out what they were scraping, protein analysis, what sort of animals they were scraping with that scraping tool. Okay, there you can see it in more detail. So it's a unifacial scraping tool, would fit very well in any Paleoindian assemblage. Because we were able to find a new activity area, just like at Barton, with these shovel test pits, now we know where it would be worth spending the time and energy to open up a larger excavation block to better study those activities at the site. All right, and then building on that, I'm getting really into this chalcedony. I'm like, I want to figure out, where's this stone coming from? How is it formed? And how are people finding it 13,000 years ago to make stone tools out of it? Well, the interesting part is that Maryland isn't the only place that people have been studying this chalcedony. And in fact, in Virginia, near Little Rocky Creek, there's more of this material. And there's a Clovis site 13,000-year-old site where people are, again, Clovis Paleoindians are finding this stone and making stone tools out of it. So that's, these people 13,000 years ago are really good geologists, and they're knowing how to read the landscape to find stone that is workable to make stone tools. And they found a very similar stone in Virginia as they have in Maryland. So there on the right, you can see one of my flakes, not mine, but one of the flakes from Piney Grove held up next to a boulder from Little Rocky Creek in Virginia. So Paleoindians, Clovis people found this stone in multiple places and knew that it was a stone that was good for making stone tools. Fortuitously, one of my colleagues visited our site and then afterwards went hiking around the Serpentine Barrens in Maryland. Another really cool place to visit. Not much archaeology there, but really awesome landscape. The Serpentine Barrens are really spectacular. He was hiking around the Serpentine Barrens and he found some chalcedony on the ground. And so that pointed me to, and it's nearby Piney Grove. So it's nearby where these people were exploiting this stone 13,000 years ago. So we went and visited, and as always, we hiked for 3 hours and didn't find anything. And then we got back to the area where we parked, and it said a last-ditch effort. I was with one of the rangers. He said, "Oh, well, you know, the Boy Scouts used to build these little grills here, and they used the local stone. Let's go look there." So after 3 hours of hiking, we looked at these grills, and sure enough, in the grills are the chalcedony. And then we started looking around in that area, which we just walked right by when we started 3 hours ago, and we found more of the chalcedony as a float, meaning sitting as big cobbles, which indicates that it formed in some sort of context that the surrounding material was more weatherable. It has since weathered away, eroded away, and dropped out these chalcedony boulders, which, again, chalcedony is a strong quartz-based stone, so it's resistant to weathering. And if I can find it today, people clearly could find it sitting there 13,000 years ago, if they knew what to look for. And Clovis people did, for certain, better than I do. All right, but here's the Serpentine Barrens. They're really remarkable. I've been thinking a lot about how they formed and when they formed, and it's still an open question to me, but people have said maybe they didn't form in their current kind of situation until about 8,000 years ago. So I'm trying to think about, well, what do they look like 13,000 years ago? But they're these open savanna grassland-like areas, which were known hunting grounds in the contact period and likely were favorable hunting grounds throughout all of the past, I would think, because they're areas with lots of grasses where grazing animals, herds of grazing animals, would like to congregate. So that's got me thinking about Pleistocene bison and their presence in Maryland. Perhaps it's not been established, but they could have been here. And if Pleistocene bison were in Maryland, where would they have hung out? Probably in these Serpentine Barrens. And so if people are big game hunters and like to hunt herd animals, where would they have gone? Perhaps these Serpentine Barrens. And it's just so happens that these Serpentine Barrens also have chalcedony, which is a tool you can make good stone tools out of. So this is the story I'm weaving now, and I still need to do a lot more research to confirm, to test my hypothesis. Maybe it'll be rejected, but I'm working on it, and that's kind of where I'm at with that study. So lastly, social media is really powerful, and I'm really eager to continue the Maryland Fluted Point Survey and learn more about artifacts that the public are finding around Maryland. I can't be everywhere at once, so people who it's their hobby to find stone tools, I'm just happy when they share that information with me. And so recently, like a month ago, I follow these different artifact websites or Facebook feeds, and someone, Mr. Price, posted a photo saying, "Did I find a paleo point?" And I saw it, and it said, sure enough, you did find a fluted point. It's a 12,000-year-old Barnes-like point. And so fortunately, Mr. Price was really nice, really open and welcoming. I Facebook messaged him, and he said, "Oh, we can go out next week, and I'll show you where I found it." So he did. There you can see me and one of my colleagues, archaeologist with Anne Arundel County, Sean Sharp. We were out at this eroding site. So now we've there's a new 12,000-year-old archaeological site that we found. I didn't find, but now I've visited and documented, eroding in Anne Arundel County. And we hope to do more work to learn more about this site before it's all eroded and gone. And this was a direct result of public outreach and someone being receptive to speaking and sharing the information of their discovery. And then I've mentioned this a few times, but I just want to just sum it up one more time. The organic preservation is poor for 13,000-year-old archaeological sites. For most archaeological sites, organic preservation is poor. But technology to extract blood residue protein from microcracks in stone is seemingly becoming more and more feasible, and people are able to learn more about what people were hunting and eating at the end of the last ice age. And so that's another study I hope to do in the near future, funding permitted. But a recent study, similar protein analysis study, was done in the Carolinas last year, and they found really cool results on fluted points. They found evidence of extinct horse, they found evidence of bison, they found evidence of extinct bison and extinct elephant, so proboscideans. They also found evidence of bear, probably wolves, as well as deer or caribou. So this happened in the Carolinas recently. I hope to do a similar study in Maryland as soon as I can get the funding secured to do so. And if people have artifacts that they want to include in this study, I'm happy to do that as well. So I'm certainly interested to see if we find evidence of bison in Maryland, especially with my current Barron's hypothesis. And if we find elephant, that'd be awesome too. Okay. All that being said, we're returning to Barton in 2025. There's a website which you can scan here or go to, which can keep you up to date on the Paleo Digger. We're going to be there in late September. Volunteers are welcome to join, so just let me know you're interested, and I'm happy to send you more information. This also has a donation page, so we're fully funded for the Paleo Digger. We have to rent the skid steer, and that's the main kind of cost, and that's been fully funded. But if there are additional donations, they'll go to those specialized analyses like the protein analysis, like the pollen analysis, additional radiocarbon dates, so on and so forth. And then lastly, if you're even more interested in the Barton site, Archaeology X, Brian Fritz, in addition to inventing the Paleo Digger, he's also a really great videographer, and he created a documentary on the work at the Barton site, which is posted on YouTube. It's like a 30-minute long documentary, and it's been really well received. And there you can scan that or go to Archaeology X's YouTube to watch that Barton site documentary, as well as he documented inventing the Paleo Digger. So a really cool watch if you're interested in archaeology, which clearly you are if you've attended this lecture. It's another cool spot to learn more. So thank you all for your time, and I'm happy to answer any additional questions.
Awesome, Zach. Thank you. Here's a question about other promising sites that are now underwater.
Yes, definitely. So clammers, like people dredging, sometimes, I mean, they're finding artifacts, and sometimes they report the artifacts they're finding, which is great, and I hope that there's more of that. And there have definitely been 13,000-year-old artifacts found by dredging. So yes, there are important early sites that are currently submerged in the bay that I'm very interested in, and I'm working with some colleagues to try to figure out ways to find those sites and study them as well. But again, that's also really difficult because they're underwater, so sometimes under a lot of water.
All right, thank you so much. That was really interesting. I appreciate your time. Thanks everyone in the art club. Please join us again third week in June for a talk on the Indians of Brazil, moving a little further south. We'll be back to Maryland shortly. Thanks, Zach. Take care, everyone. See you next time.